Hello class, good morning. I am Teacher Sandy. So before anything else, I would like you to all stand and may I request Shai to lead the prayer. In the name of the Father, Son, and Holy Spirit. Amen. You can now take your seat. So welcome back to school. How are you everyone? Wow, that's great. Let's check your attendance. So, checking of attendance starts now. No one is absent? Wow, that's great. Okay, let's proceed. So today we will having a new topic. To make it more interesting, let's have a game. I will post it on the board. Okay. I know it seems very familiar to you. So, you will identify what kind of function is. Number 1, f of x equals to a squared plus b x plus c. Anyone? Yes, dear. You're correct. It is a quadratic function. Anyone? Anyone who can remember what quadratic function is? Yes? Okay. Yes, dear. You get it right. A quadratic function is a polynomial function with one or more variables, which the highest exponent of the variable is 2. Number 2, f of x is equal to 3x plus b. Anyone? Yes. You're correct. It is a linear function. Number 3, x plus 2 squared over 4 plus y minus y squared over 9 equals 1. Anyone? None? Okay, that is an ellipse. Anyone who know what is ellipse? Oh, an ellipse is a locus of points in a plane, the sum of whose distance from two fixed points is a constant value. Okay. So, this is our example of functions. Take deeper about function, we will dealing with ellipse. So, what is an ellipse again? Yes? You are correct. Do you know what is the conic section? No? Okay. A conic section or conic is the shape resulting from intersecting a right circular cone with a plane. The angle at which the plane intersects the cone determines the shape as shown in the figure. Now, to show the part of an ellipse and what is ellipse, we will draw it using a board, pen, and a pencil and a string. So, we will draw it like this. Like that. The two pins are representing the focus of an ellipse. So to know what is an ellipse is, every ellipse has two axes. The longer axis is called major axis and the shorter axis is called the minor axis. This is the minor axis and this is the major axis. Each endpoint of major axis is the vertex of an ellipse. So this is the major axis, this is the vertex. Each endpoint of a minor axis is co-vertex of the ellipse. So this is the minor axis, there is the co-vertex. The center of an ellipse is the midpoint of both major and minor axes. The axes are perpendicular at each center. This is the center of an ellipse. The foci always lie on the major axis and the sum of distances from the foci. So any point of an ellipse is greater than the distance between the foci. This is the focus of the ellipse. Where is the foci again? Yes, here you got it. It is on the major axis. Standard forms of equation tell us about key features of graph. Take moment to recall some of the standard form of equation we worked within the past. Linear, quadratic, cubic, exponential, logarithm, and so on. By learning to interpret the standard form of equation, we are bridging the relationship between algebraic and geometric representation of mathematical phenomena. So, the standard form of the equation of an horizontal with a center at hk is x minus h squared over a squared plus x minus k squared over b squared equals 1. The vertical ellipse with a center at hk is x minus h squared over b squared plus x minus k over a squared equals to 1. The center is at h and k. For the horizontal ellipse, the major axis is parallel to x-axis. The coordinates of the vertices are h plus or minus a and k. The coordinates of the co-vertices are h and k plus or minus b. And the coordinates of the foci are h plus or minus b and the k. For vertical ellipse, the major axis is parallel to y-axis. The coordinates of the vertices are h and k plus or minus a. The coordinates of the co-vertices are h plus or minus b and k. The coordinates of the foci are h and k plus or minus c. Solving for c using the equation c squared equals a squared minus b squared. Any question? None? So let's take an example. X plus 3 squared all over 60 plus y minus 5 squared all over 25 equal to 1. This is the example. Identify and label the center, vertices, co-vertices, and the foci. First, we determine the position of the major axis because 16 is less than 25. The major axis is parallel to y-axis. Therefore, the equation is in the form x minus h squared over b squared plus y minus k squared all over a squared equals 1. So, what is the value of a and b? This is the a, this is the b, this is the a. Anyone? Yes, you are correct. It is b is equal to 4 and a equals to b. Paano siya naging 4 and 5? We square root the value of b squared and the a squared. Kaya siya naging 4 at naging 5. How about the center? What is the center of the ellipse? Yes? Okay, very good. Negative 3 and 5. What are the coordinates of the vertices? Anyone? Yes? Yes! Negative 3 and plus or minus 16 are the vertices, or it can be negative 3 and 21 and negative 3 and 11. Negative 3 and 21, negative 3 and negative 11. So, what are the co-vertices of the ellipse? Yes, dear? You got it. It is negative 3 plus or minus 16 and 5. Or it can be 13 and 5 and negative 19 and 5. What about the foci? What was the equation again in solving the C? Very good. C is equal to plus or minus square root of a square plus a square minus b square. Oh, yes, right. Excellent. C is equal to plus or minus 3 square root of 41. And the foci is negative 3 and 30 and 49 over 80. And negative 3 and negative 20, 49 over 80. So to apply everything what we just discussed, I'm going to give paper sheets with problems to test if you understand the lesson. Okay. I will give you 10 minutes to answer. Time's up. Okay, exchange your paper to your seatmates. Let's check. Okay, who got 10? Very good. Who got 7? 7 up. Okay, 5 up. 5 below. Okay, very good. No one got 5 and below. Say. Okay, we really understand ellipse. Many real-world situations can be represented by ellipse, including orbits of planets, satellites, moons, and comets. And shape of boats, hills, and rudders, and some airplanes. Some airplane wings. Oh, an ellipse that is the set of all points x and y in a plane such that the sum of their distance from two fixed points is a constant. Each fixed point is called the focus. The focus. When given an equation for an ellipse centered at the origin, in standard form, we can identify its vertices, co-vertices, foci, and the lengths and the position of the major and minor axes in order to graph the ellipse. So, I will be posting an assignment on Google Classroom and you will pass it on time para malaki ang grade nyo. Okay, that's all for today. Thank you. Class dismissed. Goodbye, everyone.